Alright, in this video we're going to look at how to solve some different integral problems. In a few of these we're going to use the power rule for integrals. And then a few of the others we're just going to use some of the knowledge that we have about derivatives to find the integral. In this first example problem we have the integral of 4 dx. So we can't use the power rule to solve this one. But try to imagine which function can you take the derivative of to end up with the integrand for this, the 4. If we took the derivative of 4x, that would give us that 4. So then the integral of 4 dx would be 4x. The rule here is that if you just have a constant, the integral of that would be the constant times the variable of integration. And for indefinite integrals, you also have to add the plus c at the end. Plus c is the placeholder for the unknown constant. You might also be wondering, what makes this an indefinite integral problem? We talked about what an integral is. It's just that symbol. And it's the process of finding an antiderivative. But what about the indefinite part? And the answer to that we'll find out more about next week. But basically what makes it indefinite, we don't have any boundaries for the integral. If we did have boundaries for the integral, then we'd be able to find the value of the c. So anytime you have an indefinite integral problem, you're going to have plus c as part of your answer. The integral of secant squared theta d theta. This one looks a little bit different with the theta after the d. That just means that the variable of integration is theta. So this theta inside of the secant squared, we treat that as our variable. In order to find the antiderivative of secant squared, you have to think which trig function has a derivative of secant squared. And that function is the tangent function. That means the integral of secant squared theta d theta is equal to tan theta plus c. Let's look at a little bit more of a complicated integral problem. Here we have the integral of a rational function. If we were finding the derivative of this, we would use the quotient rule. But for integrals, there is no quotient rule. So in order to evaluate this integral, we have to try to re-express this problem. And to do that, you can split that fraction into 3 smaller fractions, each of them having that same denominator of x squared. And then we can go through and simplify each of these smaller fractions. In the first fraction, we have x to the 4th in the numerator and x squared in the denominator. So 2 of the x's in the numerator are going to cancel with the x squared in the denominator. The next term, we have x squared in the numerator and x squared in the denominator. Those will just cancel each other out. That means this problem reduces to the integral of x squared minus 6 plus 3x to the negative 2 power dx. Now we can just go term by term, finding the integral. To find the antiderivative of x squared, we're going to use power rule. Add 1 to the exponent, making it a 3, and then multiply out front of the x with that reciprocal 1/3. For the negative 6, all you have to do is multiply that with an x. And then for 3x to the negative 2, add 1 to the exponent to make it a negative 1, and then divide the 3 out front by a negative 1. That would just flip the sign to negative. And then don't forget the plus c at the end. You might then want to rewrite that negative exponent as 3 over x. And that would be the final answer. The integral of 5x plus 2 quantity squared dx. If this were a derivative problem, you would use chain rule to solve this. But for integrals, there is no chain rule. So in order to solve this integral, you want to rewrite the function on the inside so that you can use the power rule. If we multiply out that parentheses, we'll get a 25x squared plus 20x plus 4 dx. And now we can just go term by term, finding the antiderivative. For 25x squared, you want to add 1 to the exponent to make it an x cubed, and then you want to divide the 25 by 3. That would give us 25/3 x cubed. For the plus 20x, add 1 to the exponent to make it an x squared, and then divide the 20 out front by 2. That would give us a plus 10x squared. And then for the plus 4, just multiply that with x, and then don't forget the plus c. And that is the final answer. This one's a little bit trickier. We have a rational function, and because the denominator has 3 terms, there's no way for us to break up this rational function into a polynomial. You might, however, notice that if we take the derivative of the denominator, 3/2 x squared minus 2x plus 5, that just gives us 3x minus 2, which is the value of the numerator. Anytime that's true, that means the antiderivative is going to be a natural log. If you take the derivative of a natural log, what's inside the natural log goes into the denominator, and then the derivative of what's inside goes in the numerator. So if you have a rational function where the numerator is the derivative of the denominator, that means the antiderivative, or the integral, is just the natural log of the absolute value of the denominator. And don't forget the plus c. So here's a problem type called differential equations. This is something that we'll spend a lot more time on next semester. And this is also a problem type that you saw a little bit of during the antiderivatives day. We want to solve the following differential equations with the initial conditions shown below. This is solved whenever we find the value of the function f of x, and we know the exact value of all of the coefficients and the constant. Derivatives and integrals undo one another. If we want to find f prime of x, all we have to do is integrate f double prime of x with respect to x. F double prime of x in this case is equal to 2x. So just replace the f double prime of x with 2x inside of the integral. And now the antiderivative of 2x, we can use the power rule. Add 1 to the exponent to make it x squared, and then divide the 2 out front by that new exponent. This would simplify to x squared plus c. Now we can use the initial condition that we're given, that f prime of 2 is equal to negative 1. Well, f prime of 2, we would just replace the x with a 2, and we'd have 2 squared plus c. Now we can use this to solve for c. If you square the 2 and then subtract it to the other side of the equal sign, that means that we have negative 5 is equal to c. Rewrite the f prime of x function and replace the c with a negative 5. So f prime of x is equal to x squared minus 5. So now to find f of x, which is our goal, we can take the integral of f prime of x with respect to x. So replace the integrand with x squared minus 5. And then the antiderivative of x squared would be 1/3 x cubed, and the antiderivative of negative 5 is negative 5x. Then add the plus c. Now we can use the initial condition that was given, that f of 3 is equal to 1. Rewrite the f of x formula that you just found, replacing all the x's with 3's. That means that we'll have 1 is equal to 9 minus 15 plus c. 9 minus 15 is negative 6, and if you add 6 to both sides, you'll get 7 is equal to c. Now rewrite the f of x formula, substituting in 7 for the c. That would give us f of x is equal to 1/3 x cubed minus 5x plus 7. And that is your final answer.